Okay, good day everyone. Welcome once again. You know, after the last time show, the Facebook live show, I watched the video and I realized that the graphics was bad at all. It was bad. It was very bad. It wasn't good at all. So I decided to adopt different means of getting back to you. So this time around, what I'm going to do is that the questions that I tried to answer for you the last time, I'm going to answer them, the same questions, using the PowerPoint, so that I will post it onto the WhatsApp platform. But it will also be on the Facebook page, so that those guys that are not on Facebook, that are not on the WhatsApp pages and the Telegram pages will also have it from Facebook. So I'm going to be doing this for some time until I have diagnosed the problem and I have realized where the problem is. So when I am able to solve the problem, I will switch the Facebook live thing on, or if the other alternatives that I'm putting in place work, then we will try and then use that platform and then have our lessons. So thank you for having patience for me. I really appreciate that. And all the comments that you passed the last time, in fact, it has been very helpful and I thank you very much. So what I'm going to do is that, because because of the video size, if I answer all the questions in one video, the size will be too big. So I'm going to do them video by video. Sorry, I'm going to do them question by question. So I'll do a video by question. So when I do that, I'll post it on the platform so that you have it. When I do that, I'll post it on the platform so that we have it. So that we can do the discussion on anything that you don't understand on the Telegram platforms. So thank you very much for having patience with me. So we start with the first question. Now the first question was like this. The question was on electrostatics. And it reads, two charged spheres, 10 centimeters apart, attract each other. The key word is attract each other with a force of 3.0 times 10 raised to the power negative 6 newtons. What force results from each of the following charges, considering separately, meaning that considering these information provided here separately, what force emanates from that? So we pick the solution to the first question. That is, when both charges are doubled and the distance remains the same, that is the first part. Both charges are doubled and the distance remains the same. So when both charges are doubled, so let Q1 and Q2 be the first and the second charges respectively. We are talking about two charges. So Q1 and Q2 be the first and second charges respectively. And then F1 and F2 be the forces before and after doubling the charges. Before we double the charges, we have F1. After doubling the charges, we have F2. Good. So before we double the charges, remember that this preamble is going to run through the rest of the questions. So maybe when we get there, this particular preamble in white will not appear there. So keep this thing in your head, that Q1 always refers to the first charge and Q2 always refers to the second charge. So let these be the charge spheres that we are talking about. These two charge spheres are separated by a distance d. So applying the Coulomb's law to these two charges, the Coulomb's law states that force F1 is equal to K Q1 Q2 all over d squared. That is the two charges, the product of the two charges, and the square of the distance between them. Let's call this equation 1. Those of you that have done electrostatics, you are familiar with this equation already. So this is the force when the charges are not doubled. Good. Then what happens is that when we double the charges, What that means is that Q1 is going to be doubled. So Q1 now becomes 2Q1. And Q2 becomes 2Q2. All divided by D squared. Good. Then, when we multiply 2 by 2 and we factorize that out, that will give us F2, which is equal to 4 times that. Let's call that equation 2. Now, when we compare equation 1 and 2, when we compare equation 1 and 2, equation 1 and equation 2, we can see that K1 Q2 over D squared, K1 Q2 over D squared. So in place of this, we can put F1 there. So when we put F1 there, that will give us F2 is equal to 4 times F1. Good. But remember that F1 is given to us in the question as 3.0 times 10 raised to the power minus 6 newtons. So when we put that into this formula, that will give us this. Then finally we get this as our solution. So F2 is equal to 12.0 times 10 raised to the power negative 6 newtons. You know, this is what I was trying to do the last time, and I was writing on the board and it was not coming. So thank you very much. So that is how it is. I hope you follow the steps very well. Let's go to the next question. The B part of the question says that what happens to the force when an uncharged identical sphere is touched to one of the spheres and then taken far away. So the preamble still stands. Q1 for the first charge sphere, Q2 for the second charge sphere. So let the two charges be like this, Q1 and Q2. Now we mount the two charges on insulators. You know, the blue ones, the blue stripes here are insulators. We mount the two charges on an insulator because we are going to charge them. And if they are not on an insulator, they will not get charged. Remember that when a conductor is in contact with the earth, the conductor assumes the electrical neutral nature of the earth. So we mount the charged conductors on an insulator. So the charges on the conductor are so let K1 be negatively charged and Q2 be positively charged. Why? Because we are told from the question that the two charges they attract each other. If they attract each other, it means that they have opposite charges. Good. So what happens is that let the distance between the two of them be d. We are told about distance is 10 centimeters. I'm not going to use the figure 10 centimeters to solve this question. So I don't need it. Let me still maintain the d. Now, so from these two charges, applying the Coulomb's law, we get equation 1. F1 is equal to this. Then, what happens is that we bring an uncharged sphere close to this. The moment we bring the uncharged sphere close to this, there is this principle that we call charge, how do you call it? Charge by contact. That is one of the methods of charging a conductor, charge by contact. The moment you bring it in, you bring an uncharged body in contact with a charged body, then the uncharged body or the uncharged conductor becomes charged. So let me take it again. When it comes, look at this. The charges, some of the charges will move from this one. They will move from the charged sphere and come to the uncharged sphere. So there is equal distribution of charges. You know, one of the charges is hiding at the back there, so you can't see it. Sorry, you will see it later, don't worry. So what happens is that when the charges are evenly shared among the two identical spheres, then when it is taken far away like this, that charged sphere goes with its charges. Previously, there were 6 negative charges here. Now the number of charges on this body, this originally charged sphere, has now become 3. But from the charge quantization principle, the quantity of charge Q is equal to NE. From the charge quantization principle, what that means is that the E is an electronic charge, N is the number of charges present. You know, this formula actually is supposed to be plus or minus. The plus for positive charge and the minus for negative charge. But because for the purpose of this particular work we are doing, there's no need for the post for negative charges. So I ignored it. Okay. So when we apply the charge quantization principle to this new charge, I'm calling the new charge, formerly it was Q1. But now because the number of charges have reduced, it was 6, they have become 3, the new quantity of charge on this body is going to be affected because the number of charges have been affected. The N has been affected. The N has been halved. Why half? Half because this charge is identical to this. The spheres are identical. Because they are identical, from the charge distribution principle, the two charges will be evenly shared among the two charge spheres. Remember that the charges will move from this based on their surface areas. And because the two of them are identical, they have the same surface area. So for that matter, the surface, okay, so for that matter, the charges will be evenly distributed. So 3 here and 3 here. What that means is that the quantity of charge from Q1 to small q has been halved. So the new quantity of charge, Q, is given by this. Half NE. Half because the number of charges has been halved. The half is not coming as a result of the E. The E is a constant. Electronic charge, 1.6 times 10 raised to the power negative 19 coulombs. So the new quantity of charge on this body is this. Q is equal to half NE. But look at this. The whole of this half NE, the whole of this NE is equal to Q1. So what that means is that we can write Q is equal to half Q1 because in place of this NE, I can put Q1 there from here. Then, applying the Coulomb's law to these two charges, we get this formula. F2 is equal to K small q capital Q2 over D squared. So when we put in the value of small q, you know, previously small q is equal to half Q1, then that will give us this equation. Then when we factorize the half out, we finally get this equation. F2 is equal to half out into bracket K1 Q2 over D squared. Let's call it this equation 2. And then we compare the equation 2 with equation 1. Now we can see that what is inside the bracket here is the same as equation 1. So in place of that, we can write F2 is equal to half F1. So when we write F2 is equal to half F1, then the value for F1 again is given by 3.0 times 10 to the power negative 6. So when we put it in, we get this half of 3.0 times 10 to the power negative 6. Then the final answer becomes 1.5 times 10 to the power negative 6 newtons. This is the second question. When the two charges, when one of the charges is touched with an uncharged identical sphere, the force is reduced by half. Thank you very much. Let's go to the next question, the last one, the C. The C says that when the separation is increased to 30 centimeters. So what that means is that formally the two charges are separated by 10 centimeters. So when we apply the Coulomb's law to this, we get this formula. F1 is equal to K Q1 Q2 over D squared. Good. Then when the two charges are separated by 30 centimeters, then what happens is that when we apply the Coulomb's law, the Coulomb's force to this, the formula becomes F2 is equal to K Q1 Q2 over 30 squared. Don't let us be in a hurry to square the 30. Let me mathematically manipulate this figure small. So if I manipulate it, I can get this. You know, from the principle of indices, 3 times 10 all raised to the power 2 is the same as 30 squared, because 3 times will give us 30. Yes, mathematically makes sense. So what we do is that we still apply indices to the down part, and then we get something like this. K Q1 Q2 over 3 squared times 10 squared. Then we factorize 1 over 3 squared out. That will give us this equation. Let's call this equation equation 2. Now when we compare equation 2 and equation 1, what is inside the bracket, K Q1 Q2 over 10 squared, is the same as what is here. So in place of this, we can put F1 there. So that will give us the equation. 1 over 3 squared is 1 over 9. So that will give us F2 is equal to 1 over 9 F1. But again, the F1 is given by this. So when we substitute this value into this one, that gives us this value. Then when we simplify it, it gives us 3.33 times 10 raised to the power minus 5 newtons. So this is how the electrostatic question is supposed to be answered. There are 2 electrostatic questions that I have selected. Later, I will bring that one to, it's very difficult to do this kind of mathematical typings in the PowerPoint. Put up the animations and stuff like that. So bear with me. They will delay small, but I will definitely bring them. And there were a lot of electrostatic questions. So these 2 are what I found challenging. After that, I'll post the rest onto the platform and then you can go through them. Thank you very much. And so the next video you should be expecting is solution to the linear motion question sent in. There was one linear motion question sent in by one of our brothers. So I'll deal with that one and I'll send it. Then solution to another electrostatic question, I'll deal with that one too and I'll send it. Then solution to the wave motion and the heat question, I'll put the 2 of them together, then I'll send that video too. I'm planning of doing all of them within this week. But when everything is set, the live Facebook show will definitely come up. Thank you very much and have a nice day.